Hi and welcome back. Right, so a little bit different this time. Over the last couple of weeks, had a lot of views of the effects I'm putting into Voyager. I've already shared how I motorised the nacelles. Um, I uploaded a video at the weekend showing my weapons array. Loads of people asking, will I sell code? How have I done it? So I've put together a little video here um, sharing two programs. It's got two of the phaser strips on, one that'll be lower, one that'll be upper for different lengths, so you can see how the code alters for the two. I'm not selling it, I'm sharing this. I don't know what I'll do about the entire code when it's written, because I'm not sure how practical it'd be sharing all that, because it's going to be very specific for my model. But I'm not selling it because end of the day, this is a hobby and I do it for fun. I started building my own effects, writing the code, working it out, because I quite simply can't afford to import the tenner kits and all that. They're beyond my budget. So not going to put other people in that position. I will share what I can. So I've put together a little routine, sharing all the code for it, sharing the sound effect, and showing how it's put together. So have some fun with it. Right, so here we just have the two phaser strips running, nothing else going on, no sound added. I keep getting asked why I've used more than one board. So I'll just add sound in and we'll see what the difference is, and then you'll understand. So as you can hear, the sound doesn't sound right. All the timings are messed up. It's maybe not massively noticeable, but the strips are moving slower as well. So I'll just switch it to two boards now. Right, so I'm now got two boards connected up. So the first board, for this purposes, is the master board, which will be sending the signal. Has the LED strips on. And the second board, which is the slave, I know it's not politically correct, but that's why it's called in ITC, master and slave devices. I didn't make it up, that's what it's actually called. So, but in this one, that has the sound on, so before it fires the phaser, it sends a command to play the phaser sound effect. And these are just joined together by the A5 and A4 directly together. Because it's on my laptop at the moment, that's working as a common ground. Otherwise, I'd just have to have a ground connecting the two as well. So if I plug this back in, you can now see the timing's all on, the sound effect sounds how it's meant to sound, and it gets rid of them timing problems. So this is a bit loud. So I'll run through what I've done in the program, how it works now with you, and then do whatever you like with the code. Right, so let's have a look at this code. So you're going to need to install 3 libraries. You're going to need wire data, fast LED, and TMR PCM. I'll put a screenshot up of all of them. I assume you know how to do this, open tools and manage libraries. So the code works. We have the first one, which is my sample 2 phasers, strips firing. Install our libraries. Install both phaser strips. All these variables here are to do the calculations for moving the LEDs. A lot of it's in floats because working in decimals. A little bit for transmitting to the other Arduino. Assigning both the LED strips as different pin on the Arduino. Then the code repeats twice, two different size LED strips just going round and round. The first thing it does though is it calls phasers, which is this code, and this sends a signal to the other Arduino to play the sound file for the phasers. And the rest of the code is, actually if we look at the top one, we set a random number for the firing point. We calculate how many steps each of the LEDs is going to make based on that. We calculate how far each of the LEDs is going to move each step. We then loop through 19 times, moving both LEDs. We have a short delay between each loop of 40 milliseconds for the shorter LED strip, which is 23 pixels. The long one is 31, and that has a delay of 25 seconds, and that's just to match it up to the sound effect. We then have it fire, and that's the first program. And the second program is quite literally adding a sound card reader, checking the sound card reader's working. Why it begins, so we're trying to receive data from another Arduino, keep waiting to get a signal. Once we have a signal, command becomes number 1, and we play the audio file. Every time through the loop it resets to 0, just so it doesn't start playing and playing over again without finishing itself. And that's it. So I hope you found all this really helpful. Go have fun with it, blow up some spaceships, but in the meantime, keep trekking, keep modelling. Thank you for watching this time. Thank you. Bye bye.